Hey y'all, it's me, Miss B. This video is just meant as a review of what we've already learned. We took a whole break and didn't go over this stuff. I'm sure you were just enjoying time with your family. So I want to just go over a few basic rules before we get back into chapter 5. Now, verifying trig identities. Here are some things you need to know. I'm just following your notes. You can write it on a separate sheet of paper, but you do have some of this stuff written down. Okay, so here are the rules. You need to show that one side of the equation is identical to the other. And this is an important thing. You can only change one side of the equation. You cannot skip any steps. I did notice a lot of people were skipping steps as they were working through these problems. Make sure that you are not assuming anything is obvious. If you can't, if you have to explain what you did, then you didn't show enough work. There are a lot of people that know that I walked around and couldn't see their thought process to get from one step to the other. And so that would have been marked off on a quiz or a test. All right. I use sine and cosine to help me solve because all other functions derive from sine and cosine. Those folks who tried to change them around to the other ones, they still got the right answer, but their line of thinking may have taken longer. Okay. And then sometimes you have to use algebra to verify the identities. Okay. So we're going to spend a little bit of time going over these practice problems. Like I said, feel free to follow along. These are not in your notes, so I would just take the time to maybe write them down and follow along. Okay, so for this first one, I'm just going to walk you through them. There's not much to it other than me just doing the problems and you watching. Okay, so I have secant here and I have secant here. I'm trying to get to cosine, and I know secant can get me there. So I'm just going to put the secants outside and factor. So secant divided by secant is 1. Secant x sine squared x leaves me with sine squared x. Of course, 1 minus sine squared x, I can use my Pythagorean identity, and that is cosine squared x. We'll go ahead and change secant x to 1 over cosine of x. Then these squareds and that cancel, and I'm left with just cosine x, which is my answer. Okay, next up. I'm going to work from the left side. Actually, I'm going to work from the right side. So cosecant is 1 over sine. And cotangent is cosine over sine. Then you can see, easy as that, we just combine those fractions. Okay, so we used the reciprocal identity to get this, the quotient identity to get this, and then this was just combining combining terms of the same denominator. All right, here's another one. Let's start from the left. So I have tangent squared theta. Now, 1 plus tangent squared theta is equal to secant squared theta. So I'm going to write that down. If I subtract 1 from both sides, tangent squared theta is equal to secant squared theta minus 1. So I'm going to replace that tangent with secant squared theta minus 1. All right, then I'm going to separate into two fractions. So I have secant squared theta over secant theta minus 1 over secant theta. This squared cancels with this secant, and nothing else cancels, but I'm left with secant theta. Then 1 over secant theta is cosine of theta, which is what I wanted. Okay, this next one here is one that people had trouble with previously, so I just wanted to go over it. Let's change just one of these. Okay, so I have secant squared x times cosecant is equal to cotangent squared x minus 1. or no, it's not. It's cotangent squared x plus 1. So then I'm going to distribute that through. So I have secant squared x cotangent squared x plus secant squared x. Okay, so there's my secant squared, there's my secant squared. I want to keep those the way they are. However, this is somehow going to become cosecant. So secant is 1 over cosine. Cotangent is cosine over sine squared, of course. These cosines cancel. I'm left with 1 over sine squared x. Bring that secant squared down. We want to make sure all of our things are equal here. And then we have, that gives us cosecant squared x plus secant squared x, which is our final answer. All right. This last one here, we're going to have to do some factoring. Now, I have this, and I have a 4 and a 4. That's going to give me the difference of squares. So this is my a. Wait, let me write it here. So if I have a squared minus b squared, that gives me a plus b times a minus b. So I'm going to have cosine. So square root of cosine of the 4th is cosine squared plus sine squared times cosine squared x minus sine squared x. Now, cosine squared x plus sine squared x, that's 1. Now, I want to end up with cosine, so I'm not going to change this cosine. I want to keep it. I'm instead going to change this sine. So I have 1, we'll just drop the 1. So I have cosine squared x minus, and sine squared x is 1 minus cosine squared x. We need those parentheses because we need to distribute that through. So we get cosine squared x minus 1 plus cosine squared x. Okay, so don't forget your parentheses. All right, then we combine like terms. Cosine plus a cosine gives us 2 cosines minus 1. So that is our final answer.